Hello, let's continue our Sudoku adventure with Twinkle Twinkle Christmas Star by Randall. So we have irregular 6x6 Sudoku that uses the digits 0 to 5 instead of 1 to 6. So let's go over what that means. So the irregular means we do not have our normal 6x6 boxes. Instead, we have these regions. These regions are outlined in bold. And they all still have 6 cells each. So there are 6 of them with 6 cells each. Now, each row, each column, and each bold outlined region have the digits 0 through 5 exactly once each. In addition to that, we do have star battle rules for the zeros, which means if you're familiar with the LinkedIn games, it's the same as the Queen's game in LinkedIn, where zeros count as stars and they may not touch even diagonally. So if I have a 0 here, then I can't put a 0 in any of these cells. I mean, I also can't put it in the rest of the column, the row, or the region. So none of these cells could be 0 if I placed a 0 here. All right, just zeros though, not every digit. We also have these killer cages in the grid. These are these cells surrounded by dotted lines. Digits in a cage sum to the value in the top left. So these two would sum to 5. We could do, for example, 2 plus 3. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, a 1 cage has to be 0 plus 1. Oops, I was in the wrong mode. 0 plus, what am I doing? 0 plus 1. Now we know, okay, and the 2 cage has to be 0 plus 2. But this 0-1 pair, this is in, the zeros for the 1 cage is definitely in this region, so this can't also be a 0. So that's a 2 and that's a 0. Now we know this is not 0, 5, so this is 1, 4 or 2, 3. Okay, this is interesting. This region here needs a 0. Where can we put it? Well, this 0 being placed there by Sudoku takes 0 out of these two, but by the star battle rules means we can't have a 0 there because it would be touching diagonally. Now, we know one of these two cells is a 0. This is a really, let me keep these highlighted in green just so we can see what we're down to. This 0 also sees this by the row. This is an important star battle structure where if you've limited the star to one of two places, like a vertical domino like this or a horizontal domino, then the dominoes next to it cannot be a star. So if you think about it, if I were to put a 0 here, we couldn't put a 0 here or here because they're both touching this 0. So that's not allowed. So that means that's not a star. So actually, why don't I make all my stars yellow? We know this can't be the star, so that's 1, that's 0. Let's put a 0 in there. So that's a star. And I'm going to use like a light gray to designate everywhere that we now cannot put a star, which I think will be very useful. I think that does it. So now we know this region needs a star, so that's going to end up right there. That's going to finish off the column. This region needs a star, which is going to go right there. Finish that. And then the last 0 is right there. All right. So we finished our star battle. I can get rid of the gray. I'm just going to leave the yellow there just because it's fun to have that yellow. But okay, no more zeros. So this 6 is going to be 1, 5 or 2, 4. Don't know exactly what that's doing. Let's see. Do we need to do, let's see, 7. We don't have 6. So this is 2, 5 or 3, 4. I don't even know if these are worth marking. Like, each of them have multiple options. Okay, so we know we need 3, 4, 5 left in this region here. So there is something we can do with this region. I'm not sure what the use is yet, but these two are the same digit. Because one way to think about that is whatever this digit is, it can't repeat in this region here, but it's got to go in this row somewhere, so it's going to end up there. So let's just call that green. Let's make that green there. So we know green is the same digit. Now, I wonder if we can follow green around at all. We know that green is not in any of these. So this region needs a green. It's going to be one of these two. Now this region needs a green. We don't know if green is 2 or not. So green ends up one of these 3. That's not super useful. I wonder if we have any more like geometry like that that's going to be helpful. We know that these two cells go here. So in addition to the green, we have, I mean, I guess I could call this purple, and we could say this is a green-purple pair. Because whatever these two are can't go here, so they end up down here. So do we care about where green-purple go? Purple and this. We've got our yellow, green, and purple. We need 3 more colors. I wonder if there's a particular region that we could color that would help. This is an interestingly shaped one. I mean, I could just color the rest of this region, but I don't know if that's the best way to go about this. This cell here sees quite a bit of this region, so let's give this a color at least. Let's call that orange. So we know orange isn't here or here, and it's not 0. So orange is one of these 2 cells. We're going to need, that's kind of interesting, because this region needs an orange. We know orange is not the green or the purple. So, and it can't go here, so orange ends up in one of these 2. These kind of line up. So, I mean, they do line up. So basically, one way to think about this is this region is going to need an orange, and this region is going to need an orange. And they happen to both be in these 2 rows. So the oranges are going to come, there's going to be 2 oranges coming from these 2 rows to satisfy these oranges. So the rest of these rows cannot be orange. Where might that be interesting? Like that means orange is not 1 or 2, for one. Because these are definitely not orange. In fact, we know there's an orange down here somewhere. I don't know if I can like do more with that. This one, let's give this a color. Let's call that red. So red can't go here or here in this region. So red actually ends up in one of these 2. So this can't be red, and this can't be red because red's in one of these 2. That means this has to be the red for the column. So this cannot be orange because it's red. We know red is different than orange. And so that makes this orange, and then that makes this orange. So this is not an orange. Okay. And we know there's a red and an orange down here, but I don't know where to place those. We could give this final color. So we know that these are not any of our existing colors. We have a final color, which we'll call blue. We'll just make both of those blue. Okay. So blue is not here. So this is a red-blue pair. What's missing here? Yeah, we need a green in this row. This is the green. And then we also need a purple now in the row. So that's green and purple. This row needs an orange and a red. So that's an orange-red pair. So we know orange-red are from 3, 4, 5. Interesting. Is there anywhere else, any like low-hanging fruit elsewhere? This cell here is going to be the other green-purple, but it can't be green. So this has to be purple, which makes this the green, which makes this the purple. Okay, that's progress. I think we're gonna have to color the whole grid and then figure out how the cages give us numbers. At least that's my plan. So I am gonna need a purple, which ends up over here. Let's see. Green, yellow, purple. So we need blue, orange, red. We need blue, orange, red here. We have, okay, this is a pair. So what are the 2 remaining? We need a green. So the green ends up here. So green is 1. That's good to know. I can fill out 1s in all the greens. We should be able to place the final green right there. It's a 1. All right, that's nice. So now we know the 5 cage doesn't have a 1 in it. So it has to be 2, 3 because it can't be 1, 4. Meaning all the purples are 2, 3s. So the 6 cage doesn't have a 1 anymore. So we know we're not 0, 6 for a lot of reasons. The 6 isn't even in the puzzle. And we're not 1, 5 because the 1's here. So we have to be 2, 4. And this 2 looks down. So that's 2 and that's 4. That makes purple a 3. And whatever this is a 2. So we know 2 is blue or red, but it can't actually be red because there's already red in this row. So it has to be the blue. Okay. So that's our red. That's 5, that's 4. That's 3. All right. I wonder if I can finish my colors here. So this row is missing purple. This column, this is orange or red. Same as that 4, yeah. Blue is 2, so this is going to be the other orange red. Finish the column with another orange red. Oops. So we know that this has to be a 5 by Sudoku. That's our 4 by Sudoku. This is a 4-5 pair. All of the oranges and reds are 4 or 5. We don't know which one yet. We know blue is 2, though. So actually we know that orange has to be 5. And so all the 5s are oranges, and our 4s are reds. Okay, can fill all those out. This is a 2, it's blue. What are we missing here? How about this row? We need a 3, which is purple. This column needs a 5, which is orange. And then this row needs a blue, which is 2, and we're done. All right, neat puzzle, Randall. I may have just had a little bit of fun with that, with all the coloring and everything, but it ended up working out pretty well. The killer cages did end up resolving our digits, so I don't know if I could have like fully colored without getting any of the digits, but getting the digits did help kind of speed up the coloring at the end there. So cool puzzle. I enjoyed that. I liked the star battle aspect of the zeros, and we could finish those early. All right, well, let me know how you did, and if you enjoyed it, why not leave a like, subscribe, and a kind comment below.